The moon isn't the quiet, dead rock we've romanticized for generations. For over 5 decades, since Apollo 17's final footsteps in 1972, we've told ourselves a comforting story. The moon is fully explored, mapped, and understood, a gray satellite locked in eternal silence. But on April 6, 2026, everything changed. 4 astronauts aboard NASA's Orion spacecraft during the Artemis II mission swung around the moon's mysterious far side, the hemisphere that never faces Earth. What they witnessed up close didn't just challenge our assumptions, it felt profoundly unsettling, like staring into a landscape shaped by forces we still don't fully comprehend. Imagine this. You're hurtling through space at tens of thousands of miles per hour. The familiar blue marble of Earth slips away, replaced by the stark cratered void of the lunar far side. No radio contact, no backup. Just you, your crewmates, and a battered ancient world that seems almost hostile in its indifference. That's the reality the Artemis II crew faced for about 40 minutes of communications blackout. Their experience forces us to rethink not just lunar science, but our place in the cosmos. Today, we're diving deep into what made their observations so disturbing, blending the raw mission details with fresh analysis on why the far side feels terrifying in ways that go beyond mere geology. Let's start at the beginning of this journey. The crew read Wiseman, commander; Victor Glover, pilot; Christina Koch, mission specialist; and Jeremy Hansen, mission specialist, represented a historic milestone. They included the first woman, the first black astronaut, and the first non-American to travel beyond low Earth orbit. Launching atop the massive Space Launch System, SLS rocket, on April 1, 2026, from Kennedy Space Center, they rode a beast standing 322 feet tall with 8.8 million pounds of thrust. That initial burn propelled them onto a free return trajectory, a safety-first path where the moon's gravity would naturally sling them back home even if engines failed completely, much like Apollo 13's desperate lifeline decades earlier. This wasn't a casual trip. The far side flyby put them roughly 4,670 miles above the surface at closest approach, making them the most isolated humans in history. For those 40 minutes behind the moon, every signal from Earth vanished. No mission control updates, no reassuring voices from Houston, just silence and the raw vista below. Pilot Victor Glover struggled to articulate it even before blackout, saying humans might not have evolved to process such a sight. When contact dropped at 6:44 p.m. Eastern, the crew was utterly alone with a terrain that records 4 billion years of cosmic violence. To appreciate why this felt so eerie, consider the stark contrast between the moon's two hemispheres. The near side, the one we see from Earth, features those iconic dark seas or Maria vast plains of ancient lava that flooded huge impact basins billions of years ago. About 31% of the near side is covered in this smooth basalt, giving it a familiar, almost gentle appearance we've painted and mythologized forever. The far side? It's the opposite. Less than 1% Maria, dominated instead by overlapping craters upon craters, like a surface relentlessly hammered without relief. The crust here is about 50 kilometers thicker, creating an asymmetry scientists still debate. One leading idea points to a colossal impact near the South Pole early in the moon's history. This event created the South Pole Aitken Basin, the largest known crater in the solar system, spanning roughly 2,500 kilometers across and up to 13 kilometers deep. Picture something the size of the distance from Texas to Virginia carved into the moon, with rim mountains towering 8,500 meters high. Beneath it lies something even more unsettling, a massive dense anomaly detected in 2019 by combining Grail gravity data and Lunar Reconnaissance Orbiter topography. It's a blob weighing at least 2.18 quintillion kilograms, equivalent to a metallic mass 5 times the big island of Hawaii buried deep in the mantle, possibly the leftover core of the impactor itself. This bullet fragment warps the basin floor downward by over half a mile, and a gravitational ghost lingering for eons. The Artemis II crew became the first humans to glimpse the eastern edge of this basin with their own eyes, under direct sunlight illuminating about 21% of the far side from their unique angle. Apollo missions never quite captured this view due to different trajectories and lighting. The crew's path deliberately swept them over key features, including the Oriental Basin, a bullseye-like 600-mile-wide scar straddling the near-far boundary, dated to about 3.8 billion years old. They trained rigorously in places like Iceland's volcanic fields to sharpen their geological eyes, even though they were primarily pilots and engineers rather than scientists. Christina Koch remarked on how fresh, smaller craters appeared shockingly bright against the age-gray backdrop like pinholes in a lampshade letting light through. Victor Glover fixated on the Terminator line, where sunlight grazes the surface at extreme angles. Craters along this boundary cast shadows so profound they resembled bottomless pits or black holes plunging toward the moon's core. He called it full of magic, but in a way that hinted at unease light and darkness, playing tricks that made the landscape feel alive and unpredictable. Meanwhile, Koch and Hansen photographed features like Vavilov Crater on the rim of the older Hertzsprung Basin deep on the far side. Houston's science team adjusted observation plans live based on their reports. They also noted subtle color variations, browns, greens, and blues, that orbiter cameras often flatten out. Human vision picked up these mineral and age clues, potentially rewriting lunar geological timelines. These aren't just scenic details. They touch on deeper mysteries that feel almost alien. For instance, a 2023 study identified a thermal anomaly on the far side, a 50-kilometer-wide patch about 10 degrees Celsius warmer than surroundings, likely a buried granite block. Granite typically needs water and plate tectonics to form processes the moon supposedly lacks. This suggests a dormant volcano remnant from 3.5 billion years ago with lingering heat. It raises uncomfortable questions. What other unexpected Earth-like processes might still simmer beneath the surface? Is the moon as geologically dead as we assumed? Then there are the lava tubes, potential underground networks from ancient flows, with entrance pits visible from orbit. These caverns could be vast enough to house future habitats, shielded from radiation and temperature swings. But their interiors remain speculative. Trapped gases, pristine minerals, unknown structural risks. Future missions might explore them, but for now, they represent sealed chapters of lunar history. During the flyby, the crew witnessed something extraordinary, a prolonged total solar eclipse from lunar orbit. As Orion passed behind the moon, the sun vanished for about 54 minutes, far longer than Earth-based eclipses. The solar corona flared like a halo, ringing the entire lunar disk. Hansen described the sun lighting up the moon's jagged limb, silhouetting ridges and peaks against the white-hot atmosphere. Both Hansen and Weisselmann reported spotting brief impact flashes on the surface, possible micrometeorite strikes visible during the darkness. These transient luminous events have puzzled Earth observers for centuries. Some are confirmed impacts. Others may be dust or outgassing. The far side, unprotected by any atmosphere or magnetic field, endures the full brutality of space, solar wind, cosmic rays, and debris. This isolation amplified the human element. The crew endured deep space radiation during solar maximum, when solar particle events peak. Galactic cosmic rays, high-energy particles from supernovas, penetrate shielding and can damage DNA. Apollo astronauts reported visual flashes from particles hitting their retinas. Some later faced higher cataract rates. Artemis II carried an avatar payload with the crew's own bone marrow cells to study radiation effects. Biology, not just engineering, may hold keys to longer missions. During blackout, a solar storm could have been catastrophic with no immediate warning. The Orion capsule offered better protection than Apollo, but the crew trained for worst-case scenarios: pressurized suits, continuous oxygen flow. When signal returned, they described Earth setting behind the lunar horizon, a poignant Earth set, mirroring Apollo 8's famous Earthrise, but reversed, our home planet vanishing behind gray rock. Koch reflected that this perspective reveals how much Earth provides everything we need, a unity we overlook until seen from the other side. They even named craters, Integrity for the spacecraft, and Carol honoring Weisselmann's late wife, a bright spot potentially visible from Earth. The mission set records, reaching over 252,000 miles from Earth at peak distance, with closest lunar approach at nearly 61,000 miles per hour. They captured thousands of photos, though full downlink awaited splashdown on April 10, 2026, off San Diego. These images and descriptions will refine future landing sites. Terrain that looks safe in photos might hide hazards in human-perceived shadows and textures along the Terminator. The far side isn't just scientifically rich, it's strategically vital. China's Chang'e 4 landed there in 2019, inside von Karman crater within the South Pole Aitken Basin, using a relay satellite for communication. Its rover found mantle minerals excavated by the ancient impact. Chang'e 6 later returned far-side samples, the first from that hemisphere. Beyond competition, the far side offers unparalleled radio quiet, shielded from Earth's electromagnetic noise by 3,400 kilometers of rock. Telescopes there could probe low frequencies blocked by our ionosphere, revealing the early universe like never before. Consider a parallel from Earth exploration. In 1911, Roald Amundsen's team reached the South Pole, facing isolation and unknown terrain that tested human limits. Similarly, the Artemis II crew's blackout echoed historical point-of-no-return moments, like early submariners losing contact in the deep ocean. One relatable anecdote: imagine a solo hiker in a remote canyon at night, where shadows play tricks and every sound feels amplified. Glover's description of the Terminator's black holes evokes that primal unease, our brains wired for daylight savannas suddenly confronting a world of eternal bombardment. Another example draws from modern aviation. Test pilots like Glover, with experience on the ISS, train for system failures, Yet even he struggled to describe the far side, suggesting a cognitive limit. Think of astronauts like Apollo 8's Bill Anders, who captured Earthrise and later reflected on Earth's fragility. Artemis II flipped that script with Earthset, reminding us of vulnerability from the backside. A more contemporary tie-in. Researchers studying extreme environments, like those in Antarctica's dry valleys, moon-like in their desolation, report similar awe mixed with disquiet. One glaciologist described feeling small and temporary amid ancient ice that records climate history, much like the far side's crater record, preserving solar system impacts the near side's lava erased. Or consider deep-sea submersible dives to hydrothermal vents. Unexpected heat sources and bizarre formations challenge assumptions about dead zones, mirroring the far side's granite and possible warm spots. These stories highlight a pattern. Exploration often reveals not just new data, but how unprepared our senses and models are for alien realities. The crew's training in Iceland walking lava fields to practice real-time description mirrors how mountaineers or cave explorers prepare for disorienting environments. One imagined crew moment. During blackout, perhaps they shared quiet reflections, bonding over the shared isolation, much like Shackleton's Endurance crew finding camaraderie in Antarctic peril. From my perspective, what makes the far side terrifying isn't horror movie dread, but existential unease. We've built civilization assuming the moon is a passive backdrop, a clockwork companion. Discovering asymmetry, thicker crust, buried masses, unexpected heat, forces us to rewrite lunar formation models. The giant impact hypothesis for the moon's birth already involves violence. The far side suggests ongoing ripples, like a body that never fully healed. This challenges our comfort with settled science. Every new detail, the magnetic swirls like Reiner Gamma, a bright pattern over a crustal anomaly, possibly shielding or something stranger, the lava tubes as potential shelters, hints at a more dynamic past, perhaps even remnants of processes we associate with living worlds. Radiation risks add a human layer. We're not evolved for deep space. Our biology protests. The Avatar experiment underscores this. We're probing our own cells' resilience, blending medicine and astrophysics. It raises ethical questions for future colonies. Will we genetically tweak humans or engineer habitats to mimic Earth's shield? The far side's radio silence is a double-edged sword, a pristine observatory, yet a reminder of our noisy, invasive presence elsewhere. Analyzing the mission's broader implications, Artemis II isn't just a stepping stone to landings, it's a psychological test. Seeing Earth vanish drives home planetary stewardship. Koch's words about commonality echo environmental awakenings from space, yet the terrifying aspect lingers in unknowns. What if subsurface activity, moonquakes detected by Apollo, signals ongoing geology? Or if impact flashes indicate higher risks for surface ops? These push us beyond tourism to serious science and perhaps humility. Critically, international efforts like China's successes show collaboration potential amid competition. The far side, as a quiet post, could foster global radio astronomy, listening to the cosmos without terrestrial interference. But it also spotlights how little we know. Basing moon models mostly on near-side data is like sampling one continent and generalizing Earth. The far side records the real story, unerased impacts, shifted axes, magnetic ghosts. In the end, Victor Glover nailed it. The moon isn't a poster in the sky. It's a real place, ancient and complex. The crew's observations, though brief, humanize the void and expose our illusions of mastery. The ultimate takeaway: true exploration demands embracing discomfort and uncertainty. The moon's far side teaches that what we think we know can shatter with one new perspective. It urges us to approach space and our own planet with curiosity over conquest, science over assumption. Next time you gaze at the full moon, remember, half of it hides stories that rewrite our origins. Support missions like Artemis, not for flags or glory, but for the hard truths they reveal about our cosmic neighborhood and ourselves. We haven't conquered the moon. We're only beginning to listen to what it's been trying to tell us for billions of years. Push forward with humility, because the universe rarely matches our comfortable maps.